Sending your cloud traffic through the internet is like a busy bee trying to get to its destination. In this video, we will review Google Cloud Platform's VPCs. This is part 1 of this series. Each part will go deeper and deeper. If you have not yet subscribed to my channel, please do so now so you don't miss any important updates. Please watch the complete video and then attempt this on your own Google Cloud account. As you can see on this page from Google Cloud's website, Google Cloud VPCs are global, which means that they behave differently than AWS VPCs. I will put a link in the description. I suggest that you always refer back to Google Cloud's documentation, as it is a very good learning resource. A global VPC means that your resources can access each other regardless of where they are located. In my AWS VPC series, you can see that in order for resources in the US East region to speak to resources in the US West region, you need to configure VPC peering. Not so in Google Cloud. Subnets are always the same in all accounts in your default VPC, a 10.28/9. Let's take a look at our default VPC. Yours will look exactly the same. Open the VPC tab and you can see all the regions and respective subnets. Click on the firewall to see the 4 default firewall rules. For this scenario, we are mainly interested in ICMP or pings. We can also see the route table, which includes routes to all regions. One thing that I like about the GCP dashboard is that all my resources are there in one screen. If I have one compute engine, like in this scenario in the US Central region, and one in the Asia Southeast region, I don't have to go looking for it. It's all right there with easy access to SSH into. In AWS, I have to switch between regions in order to access my resources or open a new tab for each region. It's not that it's better, it's just different. Let's check the IP addresses of each compute engine and then attempt to ping across the pond. As you can see here, pings are successful in both directions using internal IP addresses. This never touches the internet. As you know from RFC 1918, private IP addresses cannot transit the internet. Sending your cloud traffic through the internet is like a busy bee trying to get to its destination. It never flies a straight path. Plus, it's not the most secure. With Google's VPC, your traffic is transiting Google's backbone as fast and secure as possible. In the next video, we will discuss VPC custom mode. If you like this video, please subscribe, please give me a thumbs up, and smash that notification bell. I will be posting many more tutorials. In this video, we will review Google Cloud Platform VPC custom mode. This is part 2 of this series. As you can see on this page from Google Cloud's website, Google Cloud VPCs come in 2 types, auto mode and custom mode. In the previous video, we reviewed auto mode, and as you saw, there was not much to it. We really didn't have to configure anything. Custom mode VPC allows you to control everything, but there are some gotchas that you have to be aware of. As mentioned in this document, no subnets are created for us. So let's create our custom VPC by going over to the VPC menu option and then click on Create VPC Network. We give it a name, a description, and then we also have to create our subnets. The nice thing about this is that you can choose which regions you want to use. Today we will use 2 regions. I will add a subnet for the US Central 1 region, and I will make this a 10.1.0.0. As with all routing, we have to make sure that our network is in the correct format. For US Central 1, we will pick 10.1.0.0 with the /24. Once you create this first subnet, we are done. But you can also add a subnet here while you're creating the VPC, but let's do it this way. We'll show you a way to do this in case you already have a custom VPC set up and later on you want to add a region. So this takes a little bit, a few minutes for the custom VPC to come up. So we wait. In the meantime, if you have not yet subscribed to my channel, please do so now so you don't miss my next video. But please watch the complete video and then attempt this on your own Google Cloud account. As you can see, our VPC is now ready. Now we will add a subnet in the Asia East 1 region. In here, I would like to show you one little detail. And like the other one, we name our VPC. And here under IP address range, we have to make sure that we don't have overlapping IP addresses. So for this region, we will choose the 10.2.0.0 network. And once you add it, it takes a few seconds for it to populate. One other thing that you do not have any of are firewall rules. There are no firewall rules when you create a custom VPC. Basically, you can't access anything. So we have to create at least one firewall rule. And we will use pings to test our connectivity from the US Central region to the Asia East region. So we can name our firewall rule, anything that you want. It's good to put a description, and I'll just say it's allow ICMP from everywhere, allow ICMP all, and just make the name the same as the description. And here we select our IP address range or source IP address. This one that you see here, this basically means anyone, anywhere in the internet can send ICMP or pings. And we have to take a look at the protocol because we're not specifying a port. We will click on other protocols and specify ICMP. Now that that's ready, we will be able to test. And if we take a look at the routes, we will see that these do get populated automatically, which is a very nice feature. If you've done networking and understand routing protocols, you've heard of static routes and you've heard of dynamic routes. And here we did not have to create the static route It was dynamically created for us in our VPC. And now that we have two VPCs, we have to be careful, because now we have to take a look at what network we are looking at. So we have to look at, if we're looking at the routes, all the routes will be there for all VPCs, the default one and the custom one. So we could filter that. Another way to take a look at this is to sort it. And if we sort it by the network type, we will see our custom VPC routes and our firewall rules. Now let's create two instances, one in US Central 1 and one in Asia East 1. And when we take a look at this, everything seems normal. It doesn't seem like there is a way to specify that we don't want the default VPC. So we have to come down to this area and to the network interface and to the network. Here's where we choose our custom VPC. And now you see the subnet that we created, 10.1. Now we could just create or launch this compute engine. One little thing that I forgot is to change the compute engine type. So we don't want to incur too much cost in building this network out. We take a final look at our configuration, and then we launch this compute engine instance. And while this instance is launching, we don't have to sit and wait. We can create our instance in the Asia East region. And because we created the first one, we might feel a little comfortable and might think that we could skip some steps. But I want to show you something here. If we attempt to skip steps, what will happen when we come down and try to change our networking? So we pick the custom VPC, and you will see that we only have US Central region here. Why? Because we skipped the step. Here in the regions, we have to pick the region that we want. And now the menu options change, and they allow us to pick our custom VPC and the correct subnet. If we had more than one subnet in the Asia region, it would allow us to select it. And now that our instances are launching, we can attempt to SSH into them and see if pings will go across the pond and see if everything is working. Now that they're both up and running, let's attempt to SSH into both of them. One thing that you will notice is that the internal IP addresses are assigned correctly. US Central 10.1 network, East Asia 10.2 network, and they also got assigned external IP addresses, but we won't worry about those for now. And we will attempt to SSH, and as you could determine now by the time it's taking, it seems like this is not going to work. Let's try to SSH into the Asia one and see if we can get into that one. It just seems to be timing out. What could it be? Can you take a guess at this point why SSH is not working? Well, if you recall, there is nothing created for us when we use a custom VPC. We have to enable everything. The subnets were not created for us automatically. We had to do it. The firewall rules were not there. And we only created one firewall rule. Do you remember what it was? ICMP. So by default, there is an implied deny all statement. And here we take a look at our firewall rules, and you see we only have ICMP, permit ICMP. At the end of that permit, there is the implied deny all, which denies SSH, even from Google Cloud's own console. So let's allow SSH now, and this should get us working. And we want to allow from all instances in the network. We want to allow anyone on the internet to be able to SSH into these instances. And we will select TCP port 22, as you know, for SSH. And now this firewall rule gets created and added quite fast. Now let's go back and see if we can SSH into our compute engine. And we will just attempt one because we know the rule applies to all of them. It's all instances in this network. And that's the beauty of this. We don't have to go into each VPC in each region to enable our security policies. These security policies apply in our entire global Google VPC. But it seems that this is going to time out. It doesn't seem like SSH is working. And there we go. Connection failed. Why? Remember, we mentioned at the beginning, we have to make sure we are applying the rule to the correct VPC. In this example, we have two VPCs, the default one and the custom VPC. When we created the rule, we created it in the wrong VPC. So let's modify it. You will learn this lesson. You cannot modify it. Well, you cannot modify the network it belongs to. So in this case, we want to delete it because we don't want to allow SSH from anywhere on our default VPC. We actually have to create a new rule. We go through the same steps, but we have to ensure that we select the correct network. And here we go. This is our drop-down menu. We select custom VPC. Now the rule applies to all instances in our VPC, the custom VPC. And as you can see, it tells me that the name is in use because it still believes that the rule is still created. This is real time, so we're going kind of fast. So let's just create a new name for it. In the background, it believes that the old rule is still there, even though it's deleted. Now we're successful. It's creating the firewall rule. And now, good practice to always confirm on the right-hand side that the network is the correct network, which means the correct VPC. Let's go to our compute engines and let's see if we can now SSH into our devices. And it seems like it is going to work. And we see that it worked. Correct regions, correct zones. We check the IP address, do an IPA, not the beer, IP space A. And we see that we got the correct IP addresses, and we will ping across the pond. And as you know, you cannot send 10.networks or pings through the internet. So this is riding Google's backbone, undersea cables underwater fiber that belongs to Google, not touching the internet at all. What would happen if we create a new subnet in another region and add a compute engine instance in that region? Will traffic reach the new region automatically? Let's find out. Let's add a subnet in let's pick a region. Let's pick the Europe North 1 region. And we will give it a name for our standard practice. I just call it the same thing as the region. And let's pick a different subnet. And remember, we can't use the same subnets we have already used. So let's give it a 10.3 subnet. And we add this, and it should populate in a few seconds. And once it gets populated, it should be available for us to select when we create an EC2 instance. And we can also check our routes. Remember, we can sort by network, and we will see that our routes have been automatically added. That's a very good thing. So even though we have to configure several subnets, we don't have to configure the routing for them. So once again, let's create another instance. And remember, we have to pick the correct region right off the bat, or else it will not be available in our drop-down menu for the new VPC, the custom VPC. And it's available here, as you can see, under network, custom VPC. And now Europe North 1 with the 10.3 network is available. And we create this instance. And let's SSH into the US Central 1. And we can send pings across. We're still waiting for instance 3 to get its IP address to get up and running. And there we go, 10.3.0.2. Let's ping it. And there we go, successful. The routes are added automatically, dynamic routing at its finest. We don't have to worry about anything.
If you like this video, please subscribe, please give me a thumbs up, and smash that notification bell. I will be posting many more tutorials.
Does this mean that I can launch a compute engine in one VPC and a compute engine in another VPC and communicate automatically? Let's find out. Let's find out. In this video, we will review Google Cloud Platform VPC peering. This is part 3 of the Google Cloud Platform VPC series. If you are brand spanking new to VPCs, please watch the first 2 videos as each one builds upon the next. VPC network peering enables you to connect different VPCs so that resources in different VPCs can communicate using the Google backbone. In other words, your private IP addresses can communicate between them. There are 3 advantages to using VPC peering. Network latency is lower because we are using Google's backbone. Network security is increased because communication between VPCs does not have to go to the internet. And 3, network cost is reduced once again because using Google's backbone incurs a lower cost than using the internet. Let's first check our existing VPCs in this project. We have here the default VPC with no modifications and the custom VPC we created in the previous video. As you can see, the custom VPC is using 3 subnets in US Central 1, Asia East 1, and Europe North 1. In the previous video, we demonstrated a key difference between AWS and Google Cloud VPC. Namely, Google Cloud Platform VPCs are global. Therefore, no VPC peering is needed in order to communicate between regions. Whereas in AWS, you must peer regions in order to communicate with resources in different regions. Let's check our firewall rules. As you can see, we only have the 4 default rules. Now let's create a VPC network peering connection in order for our resources in different regions and different VPCs are able to communicate without using the internet. Click on VPC network peering and click Create Connection. We need 2 pieces of information in order to continue. But in reality, for this video, we only need 1 piece of information because we are only using 1 project. Give this peering connection a name and then select the VPC network. For this example, let's pretend default is my VPC network. The peered VPC network is within my project called My Project for Tutorials. The drop-down menu will then show us the VPCs that are available with select custom-VPC. Everything else will stay with default settings. The VPC network peering will show us inactive. It's a little bit of a bummer that we don't get any information at this point. We can click refresh all we want and the status will not change and we won't receive any instructions besides this. Let's check our default VPC. Nope, nada. There is nothing. Scroll to the bottom menu items and click on VPC network peering. We get the same status message of inactive. What gives? Let's go back to the VPC network peering dashboard and click on your new VPC peering connection. Finally, we get some direction. Lesson learned. Remember to look for answers. Google Cloud Platform gives us a lot, but we still have to know what we are doing. Let's go back to the VPC network peering and create a new connection. This time, let's give it a descriptive name and select the other VPC, which is custom VPC in my case. And the peered VPC network will be the default. In essence, it's the opposite of what we did with the first VPC network peering connection. And what do you know? Now both show as active. Another lesson learned. This is a 2-way relationship. Each VPC has to agree to talk to the other. Now let's look at something super cool. Click on the first connection and scroll to the bottom. What have we here? The 3 routes from our custom VPC and respective regions. Let's take a look at the other VPC network peering connection. Scroll to the bottom and we could see all of the routes from the default VPC. Now how cool is that? Does this mean that I can launch a compute engine in one VPC and a compute engine in another VPC and communicate automatically? Let's find out. I will launch a couple of instances, but I will speed this up a bit as you already know how to launch this first one will be in the default VPC. The next one will be in the custom VPC, and we will pick the Europe North region. As you recall, we only have the default firewall rules in place which allow ICMP and SSH in the default region. The custom VPC has no rules by default, therefore everything is blocked. I will add these rules in order for our test to work. Here is the moment of truth. Can I ping from US to Europe, which are on different VPCs? Yes, I can. Pings are successful. Now, like anyone that likes to tinker, let's break it. Are you ready? Let's make sure our pings are continuous. And let's delete the VPC peering connection. Yep, we broke it. Pings are timing out. If we restart the pings, you can see it's 100% packet loss. Now let's put it back together. This happens very quickly. I love it. Breaking things is one of the best ways to learn in my book. The more you break things, the more scenarios you will have in the back of your mind when it comes time to troubleshoot in the real world. In my AWS video, I discussed that transitive peering is not supported. The same is true with Google Cloud VPC network peering. In other words, your traffic cannot transit from VPC 1 through VPC 2 in order to reach VPC 3. We need a fully meshed VPC network peering. Let's demonstrate this. First, we will create another VPC with only one subnet. We don't have to get into too many details here. Once that is done, create a VPC network peering connection from default to this new VPC. In the drop-down menu, we now see the 3 VPCs. Remember that we have to create a VPC network peering connection both ways.
Please take a moment and hit that subscribe button.
Once they are both active, we can launch a Compute Engine instance. Once again, we have to create firewall rules as there are no firewall rules created by default in a custom mode VPC. Now let's test with pings. We SSH into our devices, and we can ping from the instance in the default VPC to the instance in the custom VPC, and from the instance in the default VPC to the brand new VPC, but we cannot transit the default VPC, which has routes to the secondary VPC, in order to reach the instance in the new VPC. We have to create another VPC network peering connection. Here's where you could see how messy VPC peering can get. Full mesh is no joke. If we don't give them descriptive names, it can get very cumbersome, even with 3 VPC network peers. Once we create the VPC network peering, our traffic is now successful. If we examine our routes in each of our VPCs, we will see what they know. And you will see the auto-generated route via peering statement, and it includes the VPC peering connection.
If you like this video, please subscribe, please give me a thumbs up, and smash that notification bell. I will be posting many more tutorials.